Okay, the first colligative property that we're going to cover is vapor pressure. And what I'm going to do is explaining how it will work. You have a beaker with just water, pure water, and no solute so far, right? So the water will try to go to the atmosphere with some pressure, and that's the one that we call P superscript zero. That means partial pressure of the pure solvent. That will be this value. So there is a pressure going up, and that will call P of the pure solvent. What happens when we add any solute to that one? When we add a solute, let me represent like this one. The circle will be the water, and the X will be the solute. So this one will be solvent, and this one will be the solute. So what happens is the number of particles that can go to the atmosphere will decrease, right? Because you have less on the surface of the beaker. And that's why the partial pressure or vapor pressure is lowering. So this one is less. The pure solvent have more more vapor pressure than the solution. That's the first colligative property, and that will explain the rest of them, like the freezing point depression. If you try to freeze this solution, the solute will interfere with the molecule of water to get together. Because in order to freeze, two molecules of water have to be attached close to each other, right? More tight. But it's like a barrier in between that they don't let the water to come close. So if you have this one here don't let the two molecules of water come together and become a solid. That's why the freezing point of any solvent, let's say water, will decrease. Normally, the water only will freeze 0 Celsius degree. Adding more solute will make the freezing point going down and down. And that can be -7, -10, and that's why we use salt for melting snow during the winter time. So different in temperature, we need to find the dropping will be equal to I represent the number of particles that you have in the solution. This is a constant for water or for any solvent, and this one is molality. Correct. I stand for the number of particles. How can I find I? Okay, if you use, let me scroll up. How can we find the value of I? For instance, if we are using sugar, I will be equal 1. Why is that? Because sugar will not ionize, it will not produce more than one particle. So sugar, in the case of sugar, which is a covalent compound, I will be equal 1. In the case of sodium chloride, when we add sodium chloride to any solvent, they will split in two ions, sodium and chloride. So I will be equal to the more number of particles you have in a solution, the more impact in colligative property. For instance, the vapor pressure will lower more, the freezing point will lower more, the boiling point will go higher. So if I compare sodium chloride and aluminum chloride is producing 4 particles or 4 ions. because you have 3 chloride. What will be the value of I for aluminum chloride? 4, correct. So aluminum chloride will impact more any colligative property compared with sodium chloride, and sodium chloride will be more than sugar. Okay? And the next one that I have on the board here is again is the same formula, increase of the boiling point. Water always boil 100 Celsius degree, and by adding any solute, the temperature will go up. This is a constant that is related. You always the constant is given in any problem. You don't have to memorize the constant, either one. Molality will be, just for refreshing the formula, molality will be equal to lower n for any given substance will be the number of mole of solute over kilogram of solvent. And the unit will be mole kilogram. If you are using water, don't forget that water has a density of 1 gram over 1 milliliter. So 1 kilogram in 1 liter. That will be the density of water. So sometimes in some problem, instead of giving you the mass of the water, which is the solvent, they say 500 milliliter of water or 500 cubic centimeter of water. So you can easily convert 500 milliliter of water to 500 grams. Don't forget the following conversion. 1 milliliter equals 0.001 liter. 1 kilogram equals 1,000 grams. That's another info that you need to remember for doing calculation while you are working on this one. And osmotic pressure is the next one, and that will be, if you remember yesterday I was talking about when you try to make a salad, what happens when you add salt. That will be if you have, let's say, a semi-permeable layer between the two solutions with different concentration, let's say concentration 2 greater than concentration 1, what happens is the solvent will try to go through the semi-permeable layer to go and making both concentration equal. That's why when you prepare a salad and you cut cucumber or tomato, it will take the water out of that, trying to equalize the salt that you put outside. And that will be partial pressure. The pressure that they make to the semi-permeable layer to go and make equal the concentration. The formula is partial pressure, number of particles that you have, molarity. This is different than the previous one. Molarity, for those of you who forgot, will be number of mole of solute over volume of solution, and the unit will be mole over liter. That will be